Sometimes people take this class, astronomy, just so they can understand a little bit about the constellations. Constellations are wonderful, so I hope that you take the time to kind of learn some stories about them and learn more about constellations than I can probably give you in this short amount of time. But we're going to do a little bit, okay? So we all know and love like Orion. We love Leo. Those are constellations of stars. But if indeed, and it does, if the Earth orbits the Sun, so I'm going to put the Sun here, and we'll go ahead and put the Earth here going counterclockwise. Here's my Earth going counterclockwise, okay? If that's the case, then as we look up against these background stars, well, I won't call them background stars, as we look up against these stars, okay, for instance, this pattern of strange looking stars over here would actually look different here than they look here, okay? That's because of parallax. And you can kind of see this as you move from one location to the other, things kind of scramble a little bit relative to each other. And here's a good example of that. So this is an example of parallax in action. So here we have a guy and a gal both looking at a tree. Now the guy sees the tree against the mountains, okay, and he actually sees it kind of against this right mountain range, even though he's standing on the left, just because of kind of the angle. So there's the tree. Now if we look at the gal, and we can kind of just think of these as basically maybe the same observer at two different locations. From her location, she also sees the tree, but she sees it actually now against these mountains, against the left set of mountains, okay? Are they both right? Yes. And is this parallax? Yes, because the tree appears to be different locations against the background object, which is a mountain. And this is kind of fun. No one's watching, so go ahead and do it. So hold your finger at the tip of your nose and alternate closing your left and right eye. So I'm going to do it right now. So I close my left eye, I close my right eye, left eye, right eye, and with my finger kind of just beyond my nose. So I see my finger and I see the background. And my finger appears to relocate or move against the background. And as a side note, the eye that you close and it moves the least amount actually is your dominant eye. Is that not fun or what? But that's an example of parallax. That's like two different points of view looking at something nearby, which is your finger, and the background and seeing it move. So the fact that we do actually live in a heliocentric solar system where the planets orbit the sun, we kind of have to explain why we don't see the stars kind of scramble or kind of make sort of different patterns as the Earth orbits the sun. And here's why that's the case. If you take an object and make the object very far away, it will not display parallax. If it's very far away, it will, what I say, become part of the background, become part of the solution, become part of background. And so as we orbit the sun, then basically the stars seem to keep their same pattern because they're so far away. Now, I say that, but there are some relatively nearby stars, and I can't remember what that distance is, but if a star is kind of close relative to the background stars are up here, okay, we have this kind of close star here, okay, what can happen is that star, as the Earth, here's the Earth down here, as the Earth orbits the sun, sun's in the center, 6 months apart here, this is in January, and then we have in July, that star, in January, that star appears here. In July, 6 months later, that star appears here. Okay, so that star actually, and I'm kind of exaggerating here. Is it that much of a jump? No, probably not. But it's enough of a change in position relative to the background stars to actually see parallax in action as we orbit the sun. That is so cool. And what scientists can do is that's one method they can actually get to the distance of the star. They can get to this distance right here by knowing this angle right here. It's the parallax angle.